So we've got a differential equation here, y double prime minus y equals sinh of x. We need to try and find a solution for that. Now x is our independent variable and y is our dependent variable. So what we're looking for is y of x equals something. Now on the right hand side, first thing we should notice is we've got a function on the right hand side. So we're going to need a solution in two parts. So we're going to need a homogeneous solution and we're going to need a particular solution. So the homogeneous solution, we're going to set the left hand side to equal 0, and the right hand side, the particular solution, we're going to set the left hand side as some other trial function and set that equal to sinh of x. Okay, y h of x, so the homogeneous solution is usually the easiest place to start. So let's look for that first. Okay, so let's write this up here now and set it equal to 0. So y double prime minus y equals 0. So what we know is from here we need the characteristic equation using the derivatives of y. So instead of y, we're going to use the dummy variable r, and instead of the derivative I'm going to write a 2, so r squared, and then subtract r to how many derivatives we've got here, which is 0, and then that equals 0 itself. Okay, r to the 0 we know is 1, so we can clean this up a little bit. So r squared minus 1 equals 0, and now we just need to find a value for r. So just simple algebra here, we know r squared equals 1, so r equals plus or minus 1. So we've got two different values of r, but the signs are the same. So signs are different, sorry. So plus or minus 1, different values, but the absolute value is the same. So we could say our homogeneous solution here, we can put this in here. We could use the exponential function, the cosine function, or the sinh function, or something like this. Now we've got the sinh function here, so it would be very tempting to write something like yh of x equals a sinh of x plus b cosh of x. Now if you want to go down that route, you'll have a go and see what solutions you're going to come up to. But I'm going to write it as a. Now instead of sinh of x, I'm going to use an exponential function. So e to the x, so I've got a positive 1, so it's e to the positive 1x, plus b e to the minus x. So use the minus 1. So this is the plus 1, and this is the minus 1. So just so you can see why we've got x there. If this was plus or minus 2, I'd plug in here e to the 2x, e to the minus 2x. So I'm going to use this as my trial function for my homogeneous solution. So let's just write that on here now. So a e to the x plus b e to the minus x. Okay, so that's the homogeneous taken care of. Now we're going to need to look for the particular solution. This is where things could get a little bit tricky. So let's change this now to RP. It's for our particular solution. So now we need y double prime minus y equals sinh of x. So I'm just going to write that on here. Now, my homogeneous solution here, or my trial function, is e to the x, e to the minus x. Now I've got sinh of x here. Now I'm going to use the system here for corresponding coefficients. So sinh of x, I need to translate that into the exponential form. So we know the identity for sinh of x equals 1/2 e to the x minus e to the minus x. So now we can see we've got matching terms here for sinh that we can make use of. but our particular solution here needs linearity separate to what our homogeneous function is. So what we could do is we could just put in an x where we've got our x, instead of a e to the x, we could put some constant, an x e to the x, plus another constant, and then x e to the minus x. That would be, it would be linearly independent from our homogeneous solution, which is really important. So now I'm going to rewrite this. Y double prime minus y equals 1/2 e to the x minus e to the minus x. And just close off those brackets. Okay, now using our version of this, I'm now going to write this in here as our yp of x equals, now I'm going to need some sort of linearly independent functions. So the a and the b is taken, so I'm now going to need c e to the x plus d e to the minus x. But these are still in the same form, so I'm just going to plug in an x in here to make them linearly independent. Okay, so I've got my y, so now I need my y double prime. So basically I need to differentiate these twice. So let's go one step at a time. So y prime of p of x. So integrating this one, I'm going to need the product rule. So I'll break it into c of x and e to the x. So first of all, differentiate this side. I'm going to be left with cx e to the x. Differentiate this side, I'm going to be left with c e to the x. So that's using the product rule for this one. And then something very similar with this time, with this side, but be careful with the minus sign. So differentiating this one, I'm going to be left with a minus sign with the chain rule. So that's going to be minus dx e to the minus x. And then I'm going to add on when I differentiate this one. So it's going to be left with plus d e to the minus x. Okay, now I've put a bracket in there because I don't want to confuse myself with this minus sign, because I can see if I differentiate twice, this minus was going to cancel this one out. So I'm just thinking ahead there. So y double prime p of x. So now we need to differentiate again. So we've got cx e to the x. So if I differentiate that, I've already done that before, and that's all of this. So that equals cx e to the x plus c e to the x. So that takes care of this term. This one here is just a constant multiple c. So to differentiate that, that's just going to stay as it is. So that takes care of that. So that's this term taken care of. So if I just put a line there, differentiation of that one is that one. So now I'm onto this one. So now plus, I'm going to put the bracket here so we can see what's going on. Now dx e to the minus x. Now I need to be careful here. I've done a positive version here, so here I've got the negative version. So let's differentiate this one first. So e to the minus x will become minus e to the minus x, and I've already got a minus sign here. So with the product rule, I'm going to be now left with dx e to the minus x. And now taking the derivative of this one combined with this one. So the derivative of minus dx is just minus d, and then e to the minus x. So that takes care of that. And then the derivative of this one, I'm now going to need to bring the minus sign. I'm going to have minus d e to the minus x. Okay, now need to just tidy this up a little bit. I've got brackets here which I probably don't need, and I've got c e to the x, c e to the x, minus d e to the minus x, minus d e to the minus x. So I can clean this up a little bit. So now my y double prime p of x. So I've got cx e to the x. Then this one I've got 2 of, so plus 2c e to the x, dx e to the minus x, so just go straight in without the brackets, I'm not going to need that. And then I've got two of these, so now I've got minus 2d e to the minus x. So that's my y double prime p of x. So now I'm ready to write this all in terms of this one, and sinh of x I'm going to write as this one. So what I will have now, y double prime is just this. So just put a line under this. Y double prime minus y equals 1/2 e to the x minus e to the minus x. I can now rewrite this as my y double prime will be this. So I've now got cx e to the x plus 2c e to the x plus dx e to the minus x minus 2d e to the minus x, and my y, which is this one, so it's a minus sign, so don't forget that, so minus cx e to the x and the dx e to the minus x, which, being careful, that is actually going to be a minus sign, so minus dx e to the minus x, and that's going to equal this one. So instead of writing the half in front, I'm just going to put an over 2 and take that bit out. So that equals e to the x over 2 minus e to the minus x over 2. Okay, right, so I'm going to wipe the board out and have this equation here carried on up the top here. So let's do that. So right, let's take that bit out. Okay, so now we're going to use this big long equation here, and now I'm going to separate it up now into e to the x's and e to the minus x's and do corresponding coefficients, and let's see how we can get from there. So I've got cx e to the x, 2c e to the x, and a cx e to the x. So let's do the c's first. So I've got c, I've got an x here, so I've got x e to the x. So I'm going to leave my e to the x out for now. So cx plus 2c, so that's going to be a plus 2. And I've got here a minus cx. So that's going to be just leaving me with a minus x, and that's e to the x. So you see what's happened here, these are going to cancel out. And then I'm going to deal with my e to the minus x's, which are there, there, and there. So let's write that now as plus d, open a bracket. Now factoring out all my x e to the minus x's and d's, so now I've got d, so I've got an x, I've got a minus 2, my d is already taken care of, and I've got a minus dx, so that's a minus x, and then that's e to the minus x. Okay, and that equals this. I'm going to just take this one just out of the way for now. So that equals e to the x over 2 minus e to the minus x over 2. Right, so now I need to set up my corresponding coefficients. So for my e to the x, I've got this one and this one will cancel out. So I'm left with 2c. And my e to x on this side is worth 1/2. So 2c equals 1/2. And now with my d, this one and this one will cancel out. So I've got a minus 2, e to the minus x, the coefficient here, don't forget the minus, is minus 1/2. So I've got minus 2d equals minus 1/2. Okay, well this is pretty easy to solve now. C equals 1/4, and here my d also equals 1/4. Okay, so working on my particular solution, which was cx e to the x plus dx e to the minus x. That was my particular solution. I'm now ready to add them together. So just rewriting what I scribbled out up here. y of x equals yh of x plus yp of x, which we're now ready to put in our solution for this. So y of x, now our homogeneous was this one. So we've got a e to the x plus b e to the minus x. And my particular solution, I've got cx e to the x plus dx e to the minus x, which I've now solved the c and d. So now I've got c, which is 1/4, so plus x e to the x over 4, and my d is also 1/4, so I'm now adding x e to the minus x over 4. Okay, now I've got this term here and I've got this term here. Now it'd be tempting to mix up the e to the x's and factor out with that, or I could try and work out what this is. So if I factor out an x and 1/2, so I'm just dealing with this part here now. So if I go x over 2 and factored out that, see what I'm left with. So I'm now left with e to the x over 2 plus e to the minus x over 2. Okay, now we know what that is. That's a trig identity here. This is just cosh of x. So cosh of x, let's just write that down in here. That equals 1/2 e to the x plus e to the minus x. So it's slightly different to the sinh with the minus in the middle, where this one's got the positive. So I can rewrite my solution here. Let's take these out. I can rewrite this now as y of x equals a e to the x plus b e to the minus x. Not a lot I can do here because my a and b I don't know, but this I do know. So I can write this now as plus x over 2 cosh of x. So let's just rewrite that a little bit neater. So that is then going to be my solution for this. So y double prime minus y equals sinh of x. My trial solution is going to be a e to the x plus b e to the minus x plus x cosh x over 2. Okay.